Good day, everyone. Today, let us discuss the idealized model of projectile motion. This is still the topic on the kinematics of motion. Now, if we have an object and if we allow this object to move in space, then we call this as the projectile motion. And the path followed by the object is called as the trajectory. The object in space while moving experience an acceleration vector. Now, since we have two-dimensional axes, then there must be a component along x and we have the component along y of the acceleration. The vector sum of the components, take note, is the acceleration vector of the particle, which means that the magnitude of this acceleration can be computed as the square root of the sum of the squares of its component. So this is, remember, our understanding in the vector analysis. So in order to provide the magnitude of that vector, we should have the component along the axes. Okay. Now, for idealized model, we have some assumptions to be established. The first is air resistance is negligible, which means that the air particle in space while the particle traveled, friction of that should be neglected, which means that the particle must move with a negligible air resistance. Now, because of this, because of the most of the activity is on the surface of the earth, then the x component of the acceleration must be 0 because there's no obstruction, which means that the velocity of that particle in the trajectory must have the same magnitude of velocity because the acceleration is 0, which means it undergoes a constant or uniform motion. While in the y component of the acceleration, it has a gravitational acceleration, and it is a negative g, or the negative 9.81, because the earth delivers an acceleration due to gravity by that number. Negative because it is towards the radius of the earth, means downward, and our reference point upward is positive. Y value, y above is positive while below is negative, meaning all vectors directed upward are positive while vectors directed downward are negative. Now, towards right, our x is positive, towards left is negative. So if we apply the assumptions for the Ex and Ey and substitute it to the magnitude of the acceleration, then it will come up with a negative g. Because Ex is 0 and Ey is g, therefore the acceleration of the projectile motion in an idealized model, the acceleration is negative g, or negative 9.81. What's the meaning of this? The meaning is, as the particle moves upward, climb in the curve, in moving upward, then the velocity of that will keep on reducing because of the acceleration. But the velocity along x must be the same because of the constant acceleration along x. Okay, so meaning if we have that object, for example, and we apply a force that results a velocity, call it as initial velocity. It is the velocity at the initial point wherein the frame of reference is located, and suppose the angle is theta, and the angle is theta, we call it as the angle of projection, while v0 is our initial velocity. Then the VOX, the initial velocity has the component of VOX, or the x component of initial velocity, and we have also the y component of velocity. Take note that these are the components of the initial velocity. Meaning, we can compute for the VOX given the initial velocity and the projected angle. We use the VO cosine theta. Cosine because the VOX is adjacent to the angle. Remember that this the components and the V naught will form a right triangle. That's why we have the cosine, while the VOY is a VO sine theta. So what's the meaning of this? The meaning is, if we have the initial velocity and the projected angle, we can always compute the components along x and along y. That's the principle of vector. Now, when the particle travels in space, take note that we have another position, which means we have another velocity, and this velocity surely not equal to the initial velocity. The reason is there is an acceleration which is negative z, but that negative z is only for the y component, which means that the x component of velocity must be the same because there's no acceleration, while the y component will reduce as it climbs up the curve. The trajectory, remember, because there's no acceleration along x, then trajectory must be a parabolic curve. It is a parabola open downward. So when we say parabola, there must be a vertex, and that vertex can have the axis of symmetry, which means that there are point of symmetry on this curve. Okay, so now most of the problem says that if we have the velocity, what will be the final velocity? Meaning, we need to answer the final velocity. Now, we can provide the final velocity if we have the x component or Vx and we have the Vy. So, we need the formula to solve. Now, remember that the acceleration along x is 0, then it follows that the initial velocity along x or Vox must be the same to Vx. And the proof of this is to use the previous formula in the uniformly accelerated body, that the final velocity as a function of time is equal to final velocity is equal to Vo, or the initial velocity, plus the product of the acceleration and the time. But our acceleration is 0, so that term, second term, will be cancelled out, leaving only the initial velocity. So therefore, the final velocity or Vx is equal to Vox. There is no change in velocity along x, but in y component of velocity, it must be Voy minus gt. G is the negative as the acceleration of the Earth, which is 9.81. So the final velocity along y is Voy minus gt. So with that equation, it signifies that the final velocity, if the particle will climb up the curve, then it has a reducing velocity. As the time goes on towards or the upper curve, climb up the curve, the final velocities keep on reducing until 0 in the highest point. Remember that. Okay? Now, aside from the velocity, we need to locate, to describe the particle. Aside from the velocity, we can describe it in terms of position. So, therefore, we need x. By the way, the final velocity now can be computed by taking the square root of the sum of the squares of its components. So, bx squared plus by squared. Take square root of that, the answer is the magnitude of the final velocity. Now, the x component and the y, or the x position and the y position should be determined also, because those are the instruments that we can locate the position of the particle in projectile motion. So, to compute for the positions, we need to recall again the formula in a uniformly accelerated body for the position function. Now remember that it is the position is equal to the product of the initial velocity times the time plus 1/2 80 squared. So, can you go over your notes on the position as a function of time? So, if we apply that, because we want to solve for x and y, now it happens that the second term of that, which is the 1/2 80 squared, becomes 0 because our acceleration along x is 0. So, we have only VO cosine times time, which means that we can provide the x position of that particle in projectile motion if we have the initial velocity, we have the angle of projection, and we have the time of flight or the time of travel. That's it. Vice versa. If we have the position x, and we have the initial velocity, and we have the angle of projection, then we can solve for the time of travel. Now for the y component, it should be VO sine theta times time of travel, time flight, minus 1/2 gt squared. So minus again because the acceleration is negative. So therefore, when you use this formula, do not include anymore the negative value of 9.81. Just use the 9.81 directly. So therefore, we have now the x and y, and this x and y again can trace the location of the particle in space in a projectile motion. Now, if this particle continues to move and it reaches to the highest point, again the Vx is the same as the initial velocity. So there's no change on the x component of velocity. The reason? Because the acceleration is 0. But take note, the y component is keep on reducing from initial, they keep on reducing until 0 in the highest point. So if that position is in the highest point, then Vy should be 0. Which means that the final velocity or the velocity at the highest point is just the velocity component along x. Okay? So therefore, since particle is moves with time, then again we have the position x and we have the position y. So again we can locate, meaning we have another value of x, another value of y, but we have to use the same formula but of different time. Take note, different time. Okay, so we can still use that formula. Now if that particle continues to move, so then it has now, this time it is now down to the curve, in the parabolic curve. So again, our x is the same, there's no change in x, that's why it will form a curve because of that component, but the y will tend to move downward. So from 0 component of velocity, as it moves down to the curve, there must be an increasing value of the y component of velocity, and it is now downward. So as the particle moves down, the y component is keep on increasing and increasing because of the 9.81 acceleration. Okay, so therefore we can solve again the final velocity in that point, and also we can locate the position x and y. So this is the principle of the idealized model for the projectile motion. So we can use the formula, so do not forget the formula. That formula can be applied only if that problem qualifies for the idealized model of projectile motion, meaning we can ignore the rotation, the effect of rotation of the particle, ignore the other forces that might be encountered by the particle as it moves. So then, if we ignore everything except the Earth's acceleration, then we can apply that formula. So then, we can calculate the time, if we use the position x formula. Then, solving for t now is x over VO cosine theta. So vice versa. Okay? Now, if we substitute the time, which is x over BO cosine theta, to the formula of the y position, which is BO sine theta t minus 1 half gt squared, substituting the time to that formula of y, the result is y is equal to x tangent theta minus gx squared over 2 BO squared cosine squared of theta. So it is just a matter of substituting the time to the y position. Now it becomes tangent because sine over cosine is tangent. And substitute the time to the second term, which is t squared, it will result gx squared over 2 BO squared cosine squared theta. Now, what is the use of this formula? This formula, remember, is a time-independent formula. And sometimes we call this as general equation of projectile motion. Meaning, there are a lot of problems that this formula can be used directly. Okay, so if we combine all these formulas, then these are the solutions to the problem in the projectile motion. Okay, so always remember that the general equation of projectile motion requires the meaning the y component of position is equal to x tangent theta minus gx squared over 2 BO squared cosine squared of theta. So we need the x position, we need the angle of projection, and we need the initial velocity, and we need also the angle of projection. But remember, the angle of projection in that because that formula is based on the angle, which is a positive angle in the first quadrant. Now, if the initial velocity is directed towards, for example, towards the fourth quadrant in the Cartesian, then the angle now theta becomes negative. So all you need to do, if you use that formula, be careful on the angle of projection, because the angle of projection is always coming from the x-axis towards the direction of the velocity. If the angle is a standard angle, positive, a standard angle is positive, then or counterclockwise is positive and the clockwise is negative. So again, if the projected angle is in the first quadrant, theta must be positive. But when the initial velocity is directed towards the fourth quadrant, then the angle now is in a counterclockwise direction. So therefore, it should be substituted to the formula a negative value. Thanks. Now, meaning, when the initial velocity is in horizontal direction, then the angle of projection theta must be 0. So if you use the formula, use the 0 value. Okay? So then, these are the important formula. The time independent or the general equation formula and the formula of time, which is x over BO cosine theta. Now, meaning that is the activity. This is only applicable, that formula applicable for the idealized model of the projectile motion, where air is negligible and other effects also. So that happens only, we can calculate that at any time. So notice that the general equation parabola or y as a function of the x, the angle and the initial velocity is in second degree variable if the independent variable is x. That's why it is a parabolic curve, and it is a parabola open downward because the x squared is a negative term. So it should be open downward. Okay, so the final velocity Vx, we have the Vy as the final velocity. Then we can locate the position x and we can locate the position y using that formula plus the formula of the velocities. Okay, so just memorize that formula. Okay, now to exercise ourselves on the application for the idealized model of projectile motion, let us solve this problem. The problem says that we have a physics book slides off the horizontal tabletop, meaning it is moving on the tabletop of the horizontal table with a speed of 1.10 meter per second. So it travels with that velocity. Now, it moves towards the ground and it strikes at a time of 0.48 seconds. If we ignore the air resistance, then, letter A, find the height of the tabletop above the floor and the horizontal distance from the edge of the table to the point where the book strikes the floor. So we have the table, we have the book with initial velocity of 1.10, then it moves downward in a trajectory in a remember it is a parabolic curve. Now the book strikes with a time of 0.48 seconds. Then the question is, how much or what is the height of the table? Solve it. Then what is the distance from the edge of the table towards the point of where the book strikes the floor? So it should be R. So solve for H and R. Now how to solve this problem? Now take note, this is purely an idealized model of projectile motion. So we are allowed to use the formulas. So you have to recall the general equation formula. You can use it. You can use the time, and you can use the other formulas for the velocities and the x and y. So when you observe the formula, in order to solve for A and B, take note, we need to solve for x, or we need to solve for y, or the h and r. R is our x, so and h is our y. So therefore, for x, we can use the x VO cosine t, where x now is our r, and our VO is 1.10. And theta, what's theta? Remember, theta is the angle of projection. It is the angle coming from the horizontal. Now, since the direction of the velocity of the book is in horizontal position, then theta must be 0. Okay? So meaning, it is a direct substitution of the formula x. Now, for y, you can use the y formula. So, y is equal to VO sine t minus 1/2 gt squared. So, our y is h value. Then, our VO again is 1.10, and the angle again is 0. That is the angle of projection. And the time is given 0.45. And z is, use the positive 9.81 because it is already negative. And the time is 0.48 seconds squared. Then combine. Then that's the answer for x and y. Or you can use the, after solving x, because we have already x, we can use the general equation of projectile. Okay, so let's do the solutions of the problem. So let's have two solutions for y and compare the result. So from that formula, okay, to solve for x, we use the x VO cosine t, where x is r, okay, and VO is 1.10, and the angle of projection is 0, and the time is 0.48. And substitute or simplify, the answer is 0.528. Then for the y, again, let's use the formula for the y. It is VO sine t minus 1/2 gt squared. Then y, remember, is h, and VO is 1.10, and the angle is 0, and the time is still 0.48. Then substitute, and the answer is, okay, the answer is negative 1.13 meters per second. Why negative? Negative because take note that the Cartesian, the origin of the Cartesian should be always in the initial point. So meaning it is on the top of the table. Now since h is below, so it should be negative, and that's correct. It is negative 1.13 meter per seconds. Okay, so these are the answers to the problem. Now if we compare this h, which is negative 13, if we use the formula for the general equation, can we use the general formula? The answer is yes. Why? Because we already the x, we have the theta, and we have the initial velocity, and we have the acceleration of the Earth. So substitute the values, okay, then simplify. By the way, again, the angle is 0. So substitute x, which is 0.5, because r is, or x is 0.528 along x-axis. So substitute that formula, then simplify. The answer still the same. It is 1.13 meters per second. So these are the answers to the problem. Okay, so again, it is to solve problems in idealized model of projectile motion. Be sure to pick up the given and make sure that you understand the problem given. And the first thing to do, if you are now solving, be sure that you have the Cartesian. So you have to overlay the Cartesian on the initial point of travel, which means that the reference point is always on the reference point for simplicity of the solutions, and so that we can use the formula that we derived in the previous slides. Okay, now be careful on the general equation formula, because again, when the initial velocity tend upward, then the angle is positive. If the velocity is directed toward, just like sliding on the inclined plane, then after that, at the end of the incline, there is a trajectory, or the projectile motion. So then, the angle now is negative. It is from horizontal, because the angle of projection is always coming from the positive x. So it can be positive, or positive upward, then negative downward angle. If the velocity is in the horizontal position, the angle of projection must be 0, just like in our problem solved in the tabletop. So we use the theta 0. The reason is the x is coming from, or the angle of projection is coming from x. Therefore, the angle must be 0 for the horizontal. Okay, so I think that's also kindly expand this idea, but through solving a lot of problems in projectile motion. So thank you for listening, and again, if we studied the topic and we keep on solving, learnings will be our result. Okay, so study and keep on solving. Thank you again.